All right, so now we're going to be looking at this scripting problem. And it's just a demonstration of some of the scripting capability that is within HYDRAN-XR. So if we look in there, there's the main input file is vertical cylinder, and then vertical cylinder-gin.txt is sort of the workhorse, if you will. A picture of the mesh is here in this PDF file, but what I'm going to do is I'm going to just run this thing, and then we'll work through it. But I'll run it, and then we can look at the mesh, and so we kind of know what's going on prior to going through the command. So if I open up the mesh file there. All right, so let me make this bigger. This is the mesh. Now it's not a very, you'd probably want to use a better gradation than this, but in any event, we can see that this is the mesh. The top here, it has no top. It does have a bottom, and we can see that there's 1, 2, 3, 4, 5. The discretization is 5 elements or 5 panels along the length, and here on the bottom there's 1, 2, 3, 4 along the radial direction, and then I'm not going to count these along the circumferential direction, but it's the same number obviously as around the circumferential direction of the cylinder. And of course the green is the wetted surface, and the yellow is the inside of the cylinder. All right, so that's what we're going to generate with this file. So let's go to look at those files. So this is the main file. This is vertical cylinder.txt. We're not actually doing anything, but we need this hide parameters is kind of an important command to specify regardless. We're going to specify hide coordinate axis, telling that where the center of the body fixed, the origin of the body fixed coordinate system is. And then, of course, the workhorse is this guy right here. The reason I'm putting this in here, by the way, is mainly because I want to use the hide body check command just to calculate some basic results for the mesh, just as a confirmation. All right, so let's look at this. This is the main thing that we want to look at. So, of course, /* is a comment. And so this is the beginning of the input here. Now, and this is the end of the input, and the rest of it is just code that does the work. So my convention is usually I use all caps for an array or a scalar that's is input that's not meant to be changed. So we input here the radius of the cylinder. So in other words, we can change some of these parameters to change the type of cylinder that's being generated, and then the rest of the code you don't have to change. So the radius is 10, the length is 100, the number of panels in the vertical direction is 5 as we counted. The number of panels in the circular direction or the circumferential direction is 20. That's why we didn't count those. Z0, which is the top Z coordinate, is 0. In other words, we could have put the top of the cylinder at some other location, but I'm putting it at 0. This parameter, this is an integer, by the way. These are real variables or real parameters, and these are integer parameters. So the bottom is set to be 1, and so 1 means the bottom exists, it's closed, and 0 means it's an open bottom. There wouldn't be any panels generated there in that case. Similarly, top is set in this case to be 0. We could have set it to be 1, but we set it to be 0, and 1 means closed top and 0 means open top. And as we saw, we have an open top, a closed bottom. And number of panels in the radial direction along the top and or bottom in this case just the bottom, is 4. Okay, that's the end of the input. So first I define some variables that I want to use, that I'm going to be using later. So I set a value, I set a variable equal to 1, an integer 1, integer 2, and an integer for an increment for a do loop of 1. All right, so first we're going to find the total number of panels. So that's just some multiplications and additions. So along the sides, that's just going to be the number of panels in the vertical direction times the number of panels in the circular direction, and that's then the number of panels along the vertical sides. And I'm going to copy that number to this parameter called number of panels. If bottom exists, in other words, if bottom equals 1, there is a bottom, so I need to add to that the number of panels on the bottom. And then if the top exists, I have to do the same. I have to add to that the number of panels on the bottom. All right, so then I want to find the total number of nodes. Well, that's something similar. I just need to do some additions and multiplications to calculate the total number of nodes. And again, if there are nodes, if there are panels on the top and the bottom, then I need to add those in as well. All right, so then I print the number of nodes and print the number of panels just for informational purposes. Now I need to find d theta. So d theta is going to be the delta theta for the generation. So that's related to the number of panels along the circumference, right? So I just calculate that. And then similarly, I need to find delta length along the vertical direction, and that's just the length divided by the number of panels, and I get that. So that's my delta length. drad is just the delta radius, so the increment in delta r as we generate the mesh along the bottom there. So and then again, just calculating that value. So it's just going to be the radius divided by the number of divisions, right? All right, so now we're going to put the first node on the bottom, at the center of the bottom. And so that's calculating the coordinate for that value and creating that node. And then I'm going to put the last center node on top, and that's specified there. All right, so then we're going to generate the nodes along the outer shell. And so one would need to go through this code to deconstruct it basically, but it's not that hard. I mean, to figure out what it's doing and calculating the coordinates. And so that's through here, and then we generate the nodes on the bottom, and then we generate the nodes on the top. But if first I check to see if does the bottom exist. If the bottom exists, if bottom equals 1, then it's going to do this. If bottom's not equal to 1, it's going to skip that, come down to here. So if top equals 1, if the top exists, then it's going to process this code here. But in this case, top is equal to 0, so it's going to skip that. So then I print the nodes, and I delete some. This is just, I like to clean things up a little bit. So here I'm just removing some things, some temporary variables that I don't need anymore. All right, so now data for elements along the outer shell. So here I'm creating some information for to generate the panels along the sides. And so node 1, node 2, node 3, node 4, that's we're generating 4 node quads. So again, that's calculating some information along here. Then if the bottom equals 1, so if you'll remember from the mesh, At the center here, we're actually dealing with triangular elements along that first band of elements along the bottom until we get away from the center. And so again, that's what this is doing here. And then this is the data for the quadrilateral panels on the bottom. And again, this is done if bottom is equal to 1, otherwise it's skipped. If top is equal to 1, it's going to do the exact same thing for the top. In our case, that gets skipped. All right, so now it's going to have to generate. Now it's generated the information. Now it's going to actually issue the commands to generate the panels or to create the panels. So if top equals 0, that means there's no top. And then it checks to see if bottom is equal to 1. If bottom equals 1, then it's going to generate the bottom. So if this gets generated, there's no top, but there is a bottom. So it generates the panels. Otherwise, it's open at the top and the bottom, and it just generates the panels along the edges, or sorry, along the sides. Now, if top equals 1, none of this gets processed, and it comes down here and it checks if top equals 1. It's going to do something similar, but now in the case when there's a top that exists, and it checks to see if a bottom exists. If a bottom exists, it knows. If a bottom doesn't exist, sorry, it generates just the sides and the top. And if a bottom does exist, it generates the top and the bottom and the sides. And so we use these commands here. All right, so then I print the panels just for information. I again remove some stuff I don't need anymore, which is basically most of these temporary variables. Then I export the graphics. That's what I exported the mesh in a .msh file, and that's what we opened up in the mesh viewer. And I run the hide body check command to do some checking. All right, so that's it. I mean, I say that's it, but obviously there's some thought went into creating this mesh or this file. But the advantage is it will generate any vertical circular cylinder that you want, open or closed. And if we look at the results for hide body check, again, the mesh looked fine, but one should check some basic calculations, and the 3 values of the volume from the 3 different projections are the same, and center of buoyancy is correct. It's halfway down. And so again, this command hide body check, very important, shouldn't be ignored, and you should run it as a basic check of the mesh. All right, so that's this. It demonstrates some of the scripting capability of HYDRAN-XR.